As promised, second video for examples 3 and 4. So factoring by grouping, I've done this in another video, so if you want, well, no point because I can't remember which video it is. So let's do it. When factor by grouping, we have 4 terms, then we kind of split it up, or we definitely split up into the first 2 terms and last 2 terms. So I think about how I can factor the first part. So what can I factor from z cubed and 5z squared? And the answer is z squared. After I factor the z squared from z cubed plus 5z squared, what do I have? I have z plus 5. And the way this works is z cubed divided by z squared is z, and 5z squared divided by z squared is 5. If you want to take it the other way, z squared times z makes 5z cubed, and z squared times 5 makes 5z squared. So that's how it works. I don't know if you like to think about it in terms of division or multiplication, but that's how it works. And then next, I'm going to look at this second half, and what can I factor from negative 4z and negative 20? I can factor negative 4. And negative 4 times z makes negative 4z, and negative 4 times positive 5 is negative 20. One thing you want to pay attention to is that these parentheses should always be identical. If they are not identical, there's 2 possibilities. You're either doing it wrong or you cannot factor by grouping. And it really just depends. And yeah, I'm trying to think to explain like, oh, how can you tell whether you're doing it wrong or if it's if you just can't do it. So if you're confident in your factoring skills and you look at this and you're like, oh, sometimes it might be a change of signs. So let's say I had, oh yeah, I could show you that actually. So let's say I factored a positive 4. Then in here, I would have negative z minus 5, right? So let's say you looked at this and you thought, oh, I can factor a 4 from it, which you can. You can factor a positive 4 from it. Then you're left with negative z minus 5 instead of z plus 5. And then you should look at this and be like, oh, well, they're not the same. They're not the same. Am I doing it wrong, or is it not factorable by grouping? Well, it is factorable by grouping. Like, all you have to do is change the sign, right? But if it was a different number, like 30, and it's like, oh, well, I can't, like, what can I factor from 4 and 30? I can factor a 2, right? Or a negative 2. And then these will not be z plus 5. So again, to do it correctly, the parentheses have to be the same, right? You should have this appear twice. And if it doesn't, then you either can't factor by grouping or you're doing it wrong. But to move forward, z plus 5 is being multiplied by z squared. And it's also being multiplied by negative 4. So then I'm going to rewrite it. Z squared minus 4 is being multiplied by z plus 5. Z squared and negative 4 are being multiplied by z plus 5. And then here, z squared minus 4. So that's the factor by grouping part. But this next part is that we're not done yet. I can still factor, so I'm going to keep going. So this is not factor by grouping, but this is a difference of 2 squares pattern. A squared minus b squared is a minus b times a plus b. So z squared is z squared. And 4 is 2 squared. So I'm going to take those square roots, z and 2, z minus 2, z plus 2. But you should already be familiar with that. And if not, then you could Google difference of 2 squares factoring. And you should come up with a ton of videos that give you examples of that. All right. Factoring polynomials in quadratic form. An expression of the form au squared plus bu plus c, where u is an algebraic expression, is said to be in quadratic form. So, the very first time you learned how to factor, or sorry, not numbers, but the very first time you learned how to factor polynomials, you learned something like ax squared plus bx plus c, right? The standard form of quadratic. This looks exactly the same, except instead of x, we use u. And we also tell you that u is an algebraic expression. So what does that look like? Well, instead of 16x squared minus 81, I can rewrite it as 4x squared minus 9 squared. Sorry, let me go back and explain this again. When we have something that's to a higher power, then it can be easier to rewrite it like this, so we are not confused. U squared minus 81, but I know that u is equal to 4x squared. So instead of 16x to the fourth, I'm going to say u squared, but I know that they are equal to the same thing. If u is 4x squared, then u squared is equal to 4x squared squared, which is 16x to the fourth, right? So all I've done is rewrite it in a nice and neat way for me to look at this and be like, oh, this is a difference of squares. So I'm going to say square root of u squared is u, and square root of 81 is 9. So I'm going to rewrite this as u minus 9 times, and I actually don't know why they don't show you this. That's kind of poo-poo on the book's part. U minus 9 times u plus 9. And you're like, oh, isn't that so much easier to digest than thinking about like 16x to the fourth? But after I replace my u's with the appropriate thing, which is 4x squared minus 9, and then 4x squared plus 9, there can be more factoring. And in this case, there is. This is also the difference of squares. 4x squared is 2x times 2x, right? So the square root of 4x squared is 2x, and the square root of 9 is 3. So this one I'm going to factor further. 2x minus 3, 2x plus 3. And then this one I can't do anything with. 4x squared plus 9. So there's that. So that's one example. Here's another example. So this, or sorry, looking at this, should definitely factor anything they have in common. So we go ahead and factor 3p squared right away. And then we have p to the 6 plus 5p cubed plus 6. So instead of using p's, I'm going to say u is equal to p cubed, so that I can rewrite this this right here as u squared plus 5u plus 6. And now you should be able to look at this and be like, oh, u squared plus 5u plus 6, that's really easy to factor. Well, it multiplies to 6 and adds up to 5, right? Which is 3 and 2. U plus 2 times u plus 3. And then once you get here, then you can go replace u with p cubed. Right? P cubed plus 2, p cubed plus 3. So really, u substitution is just so we rewrite it in a friendlier format. In this case, we said u squared minus 81, so we could see the difference of two squares. And then here we said u squared plus 5u plus 6, so we see that it's like, oh, it's just a quadratic. It's just a quadratic, right? Which you know how to factor. And then don't forget the 3p squared that we factored out from the very beginning. Alrighty, so yeah, that's the part I wanted to focus on, because the factoring, you know, there's just so many methods of factoring, and it can be, you know, I understand that it can be confusing, but you just have to get used to doing, you have to have done so many problems that when you look at it, you're like, oh, I get it, right? Like one or two examples is not going to get you there, but like looking at the problems and being like, okay, well, which one is it? Is it example 4? Is it example 3, 2, or 1? You know, and you'll, after you do enough, And I don't know what enough is, right? It depends. For some of you, enough is 3. For some of you, enough is 10. But once you do enough, then you'll be used to the patterns, and you'll kind of like cling to like, oh yeah, I look at this, I know what I'm supposed to do right away. If you have any questions, let me know, ask a classmate, or just rewatch the video.